Okay, good morning. Assalamualaikum. Welcome to your final class of the semester. Kita akan buat kelas full day, bukan full day, sorry. Sampai pukul 12.30 hari ni, hopefully. Maybe sampai macam hari tu, not even sampai pukul 12.30 pun. Today I'll be skipping a few chapters today. Kita akan mulakan our chapter apa ni? Chapter 9, Unit 9, Acid and Base Equilibrium. So we skip a couple of chapters because I think this is the most, this takes priority lah in understanding this module. So because of that, kamu punya final test nanti akan cover all the chapters except chapter 7 and 8. Okay, so 1, 2, 3, 4, 5, 6 dan 9. Okay, because that's the one yang kita cover dalam our semester. Tak sempat cover chapter 7 dan 8. Okay, I apologize for that. So untuk kita proceed with acid and base, saya nak mulakan the lesson. I'll start the lesson with this quizzes lesson. You can see on your screen right now, acid and base definition. Sekarang baru 15 orang, yang lagi 2 orang mungkin baru join. Aniza, Nurul Nabila baru join, so now it's 18. So bagi yang baru join, tolong pergi chat room, ada link, scroll dekat atas sikit, tajuk dia acid base definition. Ada link dekat situ, quizzes, tarikh hari ni 22 hari bulan 6. So click on the link so that kamu boleh join this quizzes lesson. Okay, so kita dah a couple of our last classes, kita dah cover about gases, solids and liquids. So as a pharmacy student, when you go, if you have a long career in pharmacy, you will be handling a lot of this stuff lah, liquid, suspensions, solid like tablets. If you work in formulation or if you work in analysis, pharmaceutical analysis, macam saya dulu, I was a chemist dekat a pharmaceutical manufacturing company. I deal a lot of this matter lah, of this substance. Saya kena buat test, I need to perform all kinds of analysis. So I deal with a lot of different phases. Saya pernah kena buat test dalam the sample ubat tu, saya kena convert daripada liquid jadi vapor, jadi gas, which is gas chromatography. I handle, most of them are in solution lah. Okay, because kalau ubat tu dalam bentuk tablet pun, saya kena grindkan dia, hancurkan dia bagi jadi powder, and then saya kena dissolve dia dalam solvent bagi jadi solution, and then I'll analyze the solution. So most of the functionality ubat ni boleh berkesan dalam badan kita. Macam mana dia bertindak balas dengan kita punya badan, kita punya organs. Most of them are affected by their pH. Okay, so in order to understand those reactions, you as a pharmacy student, kamu kena faham what is pH, and pH is basically a scale, a spectrum of acids and bases. So that's why dalam this chapter kita nak belajar tentang acid and base. So acid and base equilibrium, the title of this unit. Kalau kamu buka, saya belum upload lagi this lecture note, saya baru update. So the title of this lecture note adalah acid and base equilibrium. So equilibrium is a word, basically it means acid and base ni is not a separate thing. Dia bukan benda yang berasingan. Ini kerana bila acid bertindak balas dengan sesuatu bahan yang lain, boleh jadi acid bertindak balas dengan base, acid tu akan bertukar, dia boleh berubah menjadi neutral, ataupun dia boleh pergi go ahead to the other side of the spectrum, dia boleh jadi base. So asalnya bahan A ni, katakanlah kita ada dua bahan A dan bahan B. Bahan A adalah acid dan bahan B adalah base. So bila bahan A ni bertindak balas dengan bahan B, bahan A ni lama-kelamaan dia akan jadi neutral. And if it moves ahead with the reaction, dia boleh bertukar daripada neutral jadi basic. Itu maksud equilibrium. It does not exist on its own thing. Okay? acid tak semestinya acid. There's a under certain condition, under certain situasi, dia akan bertukar menjadi, dia boleh bertukar menjadi base. Itu masuk equilibrium. Okay, it exists in two, what's the word? It exists in two separate phase, two separate conditions under certain external forces. Kita akan tengok apa yang saya masukkan by external forces when we go into this lesson. Okay, so before kita pergi, kita explore dengan lebih lanjut, mana that quizzes tadi? Let me find, banyak sangat tab saya buka. Okay, so acid and base definitions. Bagi yang tak boleh join, kamu tak boleh participate in the exercises and the questions. Tapi kamu boleh tengok on the screen lah. Saya share saya punya screen. So kamu boleh nampak. So acid and base definition. Before you can understand acid and base reaction, you have to understand first what is acid and what is base. So dalam this, let me buka full screen. Oh, I forgot how to book up full screen. All right, this one. So kamu nampak kat sini ada tiga definition, ada tiga theory of acid and base. Kita define acid and base tu menggunakan tiga teori ni. Arrhenius, Bronsted and Lowry, and Lewis. So Arrhenius is the first theory that is developed. Arrhenius is a person, dia yang orang yang bukan orang yang pertama. He's like the fully formed idea of what is a base and what is acid. Dialah orang yang pertama yang compile semua idea yang berkenaan acid and base dan dia tulis, dia rangkakan satu definition of what is acid and what is base. So dia bukan solely the one person that is responsible for this theory. Dia basically orang yang collect all the common ideas, accepted ideas pada zaman dia, and then dia rangkakan satu theory, and that theory is widely accepted by the scientific community pada zaman tersebut. So Arrhenius is the first theory. Kemudian kita go over ahead in the future, kita ada Bronsted and Lowry theory. This is a two person, they are English chemist physicists. Bronsted is one person, Lowry is the second person, and lastly is Lewis. So all these tiga-tiga teori ni ada sedikit perbezaan. Okay, Arrhenius ada kekurangan dia because it's the first one that is developed. And then Bronsted and Lowry dia macam expand sikit definition, dia lengkapkan lagi definition of acid and base. And Lewis theory dia bukan melengkapkan, dia tambah one more aspect of what is acid and base. So Arrhenius definition, what is defined by Arrhenius of what is acid and base? Kenapa dia tak buka? Okay, so acid, according to Arrhenius, acid has hydrogen in formula and dissociates in water to produce hydronium ion H3O+. And mana dia? And base pula adalah it has hydroxy ion in formula and dissociates in water to produce hydroxy ion OH-. This is the definition of acid and base according to Arrhenius. So what does that mean adalah, this is it. So ini adalah contoh acid and base according to Arrhenius. So kalau hydrochloric acid, it is HCl. So bila dia dissociate, okay, saya guna perkataan dissociate ni, I'll try to explain this because masa saya as a student dulu, I also have this problem. Saya tak tahu apakah itu dissociate. You know by now, molecules exist in this structure lah. They are bonded, dia terikat antara satu sama lain. Contoh macam kamu tengok sekarang, HCl ni. So this is a molecule. Molekul ini terbentuk antara atom hidrogen dan atom klorin, H dan Cl. So H dan Cl ni terikat antara satu sama lain. This is a molecule. Bila dia dissociate, meaning dia break apart from one another. Dissociate is just a fancy term and it means it breaks apart. The atoms of hydrogen and chlorine yang terikat tadi tu, dia break apart. So why do they break apart? This is because kalau macam dia larut dalam solvent. So hydrochloric acid is a solute. Kalau kita campurkan dia dengan solvent, contohnya air. So dia akan dissociate. Hydrochloric acid HCl akan pecah. So dia menjadi ion. So ions are just atoms with charges. So hydrochloric acid, for example, bila dia dilarutkan dalam air, dia akan dissociate, meaning dia akan pecah menjadi hydrogen ion dan juga chlorine ion. Itu maksud dia kata kat sini, acid has hydrogen in the formula and it dissociates in water to produce hydronium ion ataupun H plus ion. Dia tak lengkap kat sini. Okay, so tak semestinya H3O plus saja, hydronium saja. It also includes H plus ion. So dekat sini, hydrochloric acid dia dissociate menghasilkan H plus ion dan juga chlorine ion. So therefore, according to Arrhenius, hydrochloric acid HCl adalah sejenis acid. So this is acid because it forms hydrogen ion, H plus in water. Kita tengok base pula, NaOH, sodium hydroxide, dia ada OH dekat sini. So according to Arrhenius, base is something that has OH in it, in the formula, and bila di dissociate in water, it produce hydroxy ion. OH minus is hydroxy ion. So sama juga macam tadi, NaOH is one molecule. It is formed by Na atom dan juga OH hydroxy ion, oxygen dan hydrogen. Bila dia dissociate in water, it produces Na plus ion dan juga OH minus ion. So kalau sesuatu molekul itu, sesuatu bahan itu menghasilkan OH minus ion, according to Arrhenius, dia adalah sejenis base. Okay, let's try this exercise. Which of the following is Arrhenius? Arrhenius base. Which one is it? Korang tak boleh join, jawab sendiri. Choose which one you think is right. Okay, these are the four. Jawapan yang betul adalah ini. Okay, jawapannya yang ada OH ni. Kenapa ramai salah? Apa maksudnya? So 4 orang. Do this mean? So ada 10 orang jawab tadi, yang 4 saja jawab betul, 6 orang salah. So macam definition of Arrhenius base yang tertulis dalam slide tadi, base is anything with OH in the formula. So kamu tengok kat sini, HNO3 tak ada OH. H2S tak ada OH. HClO4 tak ada OH. So all of these are acids. Yang ada OH hanyalah SrOH2. Okay, so therefore, the last one tu adalah base. That's the key thing yang kamu kena identify. Bila kamu nak, yang kamu kena tahu kalau kamu nak identify sesuatu bahan tu adalah acid ataupun Arrhenius, acid Arrhenius ataupun acid base. So kalau yang tak tahu 6 orang tadi tu, make sure. Okay, remember that's the key thing that you have to know. Macam mana nak bezakan antara Arrhenius acid dan Arrhenius base. Now we move on to Bronsted and Lowry definition. Acid is a substance that donate H+. Base is a substance that accept H+. The idea of conjugate acids and bases. So Bronsted and Lowry, macam saya cakap tadi, dia melengkapkan. Arrhenius tu macam tak lengkap sebab ada bahan yang according to Arrhenius, kalau kita ikut definition of Arrhenius, dia adalah acid. Tapi after we perform, after a certain reaction, kita dapati dia bukan acid, dia adalah base. Ini kerana definition of Arrhenius acid and base tak lengkap. Okay, dia tak cover all substances. So therefore, Bronsted and Lowry try to solve this problem lah. So they came out with this. They perform many more experiment. Dia dapati kita boleh define acid and base better, dengan lebih baik. by using this definition. So Bronsted and Lowry define acid sebagai satu bahan yang mendermakan, memberikan hydrogen ion, dan base pula adalah sesuatu bahan yang terima hydrogen ion tu. Okay, dia berlaku dengan serentak. It happens concurrently, simultaneously. That's the word yang saya nak pakai kat sini. Okay, it complements each other. Kalau ada bahan A dan bahan B, kita ada dua bahan ni, and bahan A bertindak dengan bahan B, macam yang ada dekat slide sekarang ni. Bahan A ada hidrogen. So bila dia bertindak balas dengan bahan B, dia akan dermakan hidrogen ini kepada bahan B. Okay, hidrogen ni pada asalnya it is bonded to A, substance A. But when it is reacted, so bila bahan A kita campurkan dalam satu beaker dengan bahan B, hidrogen atom ni dia akan berpindah kepada bahan B. So bahan A donate H plus ion to B. So by this, according to Bronsted and Lowry definition, kita akan define A sebagai acid sebab dia donate dia punya H plus ion. And B pula, because it accept that H plus ion, dia jadi base. Okay. And also, kalau kamu tengok dalam slide ni, the point number 3 adalah it introduces the idea of conjugate acids and bases. So, macam saya cakap tadi, Bronsted and Lowry dia melengkapkan lagi the idea, the definition of acid and base. Kalau Arrhenius tak ada pun, dia tak cakap tentang what is conjugate acid and bases. So, what is it? Conjugate acid and base, kita tengok dalam satu chemical equation ni. The same yang saya tunjuk tadi. Bila bahan A bertindak balas dengan bahan B, kita dah cover tadi, kalau bahan A donate dia punya H plus pada bahan B, that means A adalah acid, B adalah base. So kita tengok pula the product of that reaction. So bila bahan A bertindak balas dengan bahan B, of course dia akan hasilkan sesuatu yang baru. Remember dalam chapter 1, definition of chemical reaction, something new is formed. So dalam this chemical reaction, kita tengok bila A bertindak balas dengan bahan B, new substances are formed at the right hand side of the equation. You can see A pada asalnya adalah A, in the end dia jadi A minus. So it is now an ion. So this one adalah conjugate base. And B akan jadi conjugate acid. Okay, dia maksudnya conjugate base ni adalah hasil daripada tindak balas sesuatu asid tu. So kalau A ni adalah acid and dia donate dia punya hydrogen pada B, so it is now no longer an acid. Dia dah jadi conjugate base. Maksudnya it is in between. It could still be a base and acid depending on what happens dalam condition between A minus and B plus ni. Itu maksud conjugate. It is like in a limbo lah. It is not necessarily acidic, not necessarily basic. Kita perlu something more data to define what is it. So the term that we use to namakan A minus tu adalah conjugate base. So kalau kamu nak mudah nak faham, mudah nak ingat, just understand A minus tu adalah hasil daripada acid. So kalau A pada asalnya adalah acid, so the product of that reaction bila dia dah donate dia punya H plus, dia akan jadi conjugate base. So it works for B also. Kalau B on the left hand side kita dah identify dia sebagai base. So bila dia dah terima hydrogen ion tu, it is now a conjugate acid. So that's why bila saya kata tadi Bronsted and Lowry theory, it completes. It is more complete dia punya definition of acid and base bila kita bandingkan dengan Arrhenius theory. Okay? So itulah maksud the definition of acid and base according to Bronsted and Lowry, and what is conjugate base and conjugate acid. So this is a very simple slide. It completes the punya definition of what it is Bronsted Lowry acid and base definition. So what is the conjugate acid of H3O+? Okay, kalau tak boleh join, tengok dekat screen. CO3 2 minus ke? What is it? Okay, time's up. So, kat sini half of you got it right. 5 orang. The conjugate acid of H3O, H2CO3 minus. Okay, so what does this mean adalah, macam mana nak tahu apa nama the answer to this question. So let me buka my whiteboard. Soalannya, what is the conjugate acid of H3O plus? Okay. Alah, every time buka ni jadi rosak. Conjugate acid. So macam saya cakap tadi, conjugate acid adalah hasil daripada the word conjugate ni is the opposite of the second word. Okay, kalau kita cakap tentang conjugate acid, that means before dia bertindak balas, dia adalah sejenis base. Okay, so this is we're talking about Bronsted and Lowry, ya. Remember Bronsted and Lowry, the defined base tu adalah something that accepts H plus. Okay, so in this case kita ada apa tadi? I forgot the chemical, the HCO3 minus carbonic acid. HCO3 minus. So what is the conjugate acid of this? What is it? So maksudnya dia tanya what is the base of this? Okay, so macam saya cakap tadi, the base adalah something that accepts H plus. So just tambah H plus dekat sini. So bila HCO3 minus tambah H plus, dia akan jadi H2CO3. That's why the answer adalah H2CO3. Okay, so kalau remember just the opposite. Kalau perkataan tu the word conjugate tu ada the second word is acid, that means kalau ditanya what is the conjugate acid, just go back, reverse, tengok balik equation ni, the conjugate acid, reverse balik, kalau macam HB kan. So reverse balik kat sini, it is a base. Wait a minute, let me check balik. What is the conjugate acid of HCO3 minus? Sekejap ah. HCO3, saya takut saya define ni salah pula. Acid and base that akan produce conjugate acid tambah conjugate base. So kalau A is acid, B is base, yang kita ada kat sini A minus and BH. Kalau soalan tu tanya what is the conjugate acid of saya tak tahu, saya confused ke kamu pun ada confused juga? Later saya akan tengok balik this question. Okay, I'm sorry lah because I skim through because this is not my slide. Yeah, I'll get back to you after break nanti, pukul 10.30 kita ada break. I'll study this question again, nanti saya akan elaborate balik kenapa saya confused. Okay, what is the conjugate base of a weak acid? Sorry, will the conjugate base of a weak acid be strong or weak? Dekat sini dia dah venture into the strength of acids and bases. Kalau kamu you're not aware of the strength of acid and bases, kamu try jawab kat sini. Itu kita akan discuss. Semua jawab. So kat sini, okay. Ramai orang jawab strong. Selebihnya, kamu tahu ke kamu hentam ni? Okay, so conjugate base of a weak acid. So this is just the bizarro, terbalik saja. Okay, so kalau asalnya, kalau kamu tak tahu, acid and bases can be weak and strong. You may be aware of this masa kamu belajar about pH scale dulu. Kamu tahu acid, dia punya pH scale dia starts from 1 sampai 6. That is acid. Kalau base, dia punya scale, pH scale starts from 8 sampai 14. So a strong acid is scale-nya adalah 1. So as it go closer, as it moves closer to neutrality, to neutral, dia jadi weaker lah. So acid yang pH-nya 6, 5 tu sangat lemah. 1 yang paling kuat. The same goes for base. So as it inches closer to neutral, dia jadi lemah. So that means untuk base, pH yang base yang kuat adalah pH-nya yang 11, 12, 13 dan 14. Yang dekat-dekat dengan 7, 8, 9 tu adalah base yang lemah. So untuk bila dia bertindak balas dengan any of these acid and bases, strong or weak, bila dia bertindak balas, dia menghasilkan conjugate form. It will be the opposite of its before it reacted lah. So kalau acid tu strong acid, dia akan menghasilkan a weak conjugate base. Kalau dia adalah a weak acid, dia akan menghasilkan a strong conjugate base. Okay, terbalik kan sahaja dia punya strength. Alright. And our last definition iaitu Lewis. Kenapa dia tak buka? Okay, so Lewis definition, it explore another side of acid and base kat sini. Dia menjelaskan acid and bases according to electron. So by definition of Lewis theory, acid adalah electron pair acceptor, base pula adalah electron pair donor. So dia terbalik sedikit. Dia terbalik, tapi dia punya konsep terbalik tu is a bit different dengan Bronsted and Lowry tadi. So kalau Bronsted and Lowry, it talks about the movement of hydrogen ion. Ada hydrogen ion donator, and ada hydrogen ion acceptor. Untuk Lewis theory, Lewis definition, ada electron pair donator dan juga ada electron donor. Astagfirullahaladzim, donator. Okay, ada electron pair donor dan juga ada electron pair acceptor. So this is a chemical equation that describes the process. So kita ada fluorine kat sini, F minus. This is a Lewis base. So why is it a Lewis base? Because here dia mendermakan dia punya electron pair. And boron trifluoride BF3 adalah Lewis acid because dia terima electron pair. So in this reaction, you have to understand what is electron pair because we keep repeating that word, that term. So kamu tengok pada F ni, F minus yang saya tengah circle with my mouse right now. So kamu nampak di sekelilingnya ada like these black dots. So these black dots adalah electron pair, pasangan elektron. Okay, kat atas ni kita ada 2 biji elektron. So this is one lone pair of electron. And belah kanan dia ada another lone pair. Kat bawah ada another lone pair and dekat tepi belah kiri ada satu lagi. So fluorine ni, in its outermost valence, remember kita belajar dalam chapter 3, okay, weeks ago, you may have forgotten. Fluorine dalam dia punya outermost shell, dia boleh hold as much as 8 electron. Dalam bentuk macam ni lah, lone pair macam ni. So this 8 electron, it exists dalam bentuk lone pair. Ada 4 pasang. So by definition, kalau dia bertindak balas dengan boron trifluoride dekat belah kanan ni, BF3, boron boleh hasilkan satu lagi ikatan, a covalent bond. So dia ada lagi satu slot untuk form a bond dengan this fluorine here. So dia akan terima this lone pair of electron. So this lone pair of electron daripada fluorine ni akan mengikat boron. So that's why dia terima boron here accept this lone pair daripada fluorine. So that's why boron trifluoride BF3 adalah Lewis acid. Fluorine ion F- ni adalah Lewis base. Because acid adalah electron pair accepted. Dia terima electron pair. Base pula adalah electron pair donor. So in the end dia akan hasilkan one product. Okay, boron tetrafluoride BF4 minus. So ada pilihan kat sini dia tanya which is a Lewis acid. So untuk jawab soalan ni kamu kena boleh draw dia punya Lewis structure. So that's the, is it a weakness? Saya pun tak pasti. It's not a weakness, cuma ada satu one step, extra step. Sebelum kamu boleh tentukan sesuatu bahan tu adalah Lewis acid or base, kamu kena boleh lukis dia punya Lewis structure, which is why we learn about that dalam chapter 3. So you need a little bit more practice lah kalau kamu tak mahir lagi. So which is a Lewis acid? Kat sini dia jawab dia adalah Ag+. So why is this an Ag+? So kenapa Ag+ adalah jawapan? So tengok balik pada full question view kat sini. So Lewis acid by definition tadi adalah sesuatu bahan yang terima, mana dia? Sesuatu bahan yang terima, accept electron pair. So kat sini kamu kena tengok from all of these four options, siapa yang boleh accept, meaning dia ada sama ada dia neutral ataupun positive charge. So kat sini kita ada satu yang negatif. So this is obviously bukan Lewis acid. So kenapa negatif bukan? Because dia ada lebihan elektron. Bila sesuatu bahan tu dia ada negative charge, you have to remember electron charge dia adalah negatif. So bila sesuatu molekul, sesuatu atom ataupun sesuatu ion, charge dia adalah negatif, that means dia ada lebihan. It has an extra number of electron. So dia bukan tak boleh. It is least likely to be a Lewis acid. So kita boleh eliminate dia dulu siap-siap kat sini. Next adalah kita tengok pada H2O yang selebihnya lah, Ag+, H2O dan juga NH3. So kita nak eliminate bahan yang tak ada lebihan elektron. So kita tengok pada H2O dulu. We know Ag+ is the answer. So kita tengok kenapa H2O bukan Lewis acid. Let me go to my drawing board. Okay, so why H2O is not a Lewis acid? Kita tengok, tengok Lewis structure dia. So remember Lewis structure, kamu kena draw dia punya a central atom, which is oxygen in this case, and dia punya terminal atom, which is hydrogen, 2 hydrogens. Sekarang kamu kena agihkan elektron. So hydrogen ada 2, so ada 2 elektron. Oksigen ada 6. So total semua 8 elektron. So kita agihkan 8 elektron ni. So sekarang saya tengah nak lukis Lewis structure. Kenapa saya nak lukis Lewis structure? Because saya nak tengok adakah H2O ada extra number of electrons. Meaning dia elektron yang tak terikat. So sekarang kita ada 8 elektron. We use 4 of them. 1 dan 2 jadi 1 bond. 3 dan 4 jadi 1 bond. So we have used 4 elektron. So 8 tolak 4 elektron jadi 4 elektron. So hydrogen dah complete. Dia punya outermost shell dah ada 2 biji elektron. So we cannot add anymore. Okay, so hydrogen is complete. Tak boleh tambah lagi dah. So 4 elektron ni boleh pergi mana? Oxygen lah is the answer. Okay, so in every Lewis structure punya, kalau kamu nak lukis, you always prioritize the central atom. So in this case, oxygen masih belum lagi penuh. Okay, we need to complete dia punya octet rule. Meaning, sesuatu atom tu kena ada 8 elektron dalam dia punya valence shell. Hydrogen is the exclusion to this rule because dia hanya ada satu orbital and the first orbital hanya boleh pegang, it can only hold as much as 2 electron. So in this case, macam saya cakap tadi, dia dah complete dah 2 elektron. Satu kat sini, satu lagi kat sini. So hydrogen, both dah complete. So the other 4 electron, dia akan pergi pada oxygen. So, one lone pair and another lone pair. So this means by this Lewis structure yang kita baru kenapa dia tak boleh nak. By this Lewis structure yang saya baru lukis ni, kita boleh nampak H2O ada 2 lone pair, ada lebihan elektron. So therefore, in all of the options tadi, H2O is also least likely to be a Lewis acid because dia ada lebihan. Dia boleh donate. So kalau dia boleh donate, kenapa dia nak accept? That's why the least likely to be a Lewis acid because Lewis acid is a electron pair acceptor. Dia lebih mudah untuk terima electron pair. So kita eliminate H2O. Next adalah NH3, ammonia. So kita draw Lewis structure of ammonia pula, NH3. So the central atom is the atom yang mana ada satu saja bilangannya. Ammonia lah, nitrogen. So nitrogen is the central atom, selebihnya adalah hydrogen. So letak sekeliling dia macam ni. Kemudian kita identify nitrogen ada berapa elektron? Ada 5. Nitrogen ada 5 elektron, hydrogen ada 1, ada 3 bilangan hydrogen kat sini, so 3. So in total dia ada 8 elektron juga. So kita combine dulu, we use the electrons untuk combine this terminal and central atom. So we have used 6 kat sini. So 6. 1 electrons, 2 electrons, 3, 4, 5, and 6. So we have used 6 electrons. So ada baki lagi 2 elektron. So we always prioritize the central atom. So lagi 2 ni, dia akan go to nitrogen. So terletak satu, a crown ke atas. So this is a lone pair of electron. So dia ada lebihan electron kat sini. So it is least likely to be a Lewis acid. So the answer adalah apa tadi ya? I forgot lah. The answer tadi adalah Ag plus. So let's look. Kenapa Ag plus is the answer? I forgot Ag plus duduk kat mana. Ag, silver, transition metal. Saya nak mengelak dia tak? Senang. So kat sini, okay, so Lewis acid. So kenapa Ag plus adalah Lewis acid? Because dia tak ada sebarang ikatan walaupun dia ada lebihan elektron, but all the electrons are not bonded. Okay, so therefore dia boleh form ikatan. So dia boleh terima more electron pair. Okay, we have eliminated. Berbanding dengan water dan juga ammonia tadi, kalaulah sesuatu, this is the rule lah, maybe it is simpler for you to understand here. Kalau sesuatu atom, sesuatu molekul tu, dia ada ikatan and then dia ada lone pair. Okay, so how do you determine this? So saya takut confused because Ag tadi kamu tengok from the drawing, dia ada 5 electron pair. 1, 2, 3, 4, and 5. Okay, Ag plus. So this is the Lewis structure of Ag plus. Saya takut kamu confused because tadi saya cakap ya kalau dia ada extra lone pair, the least likely to be a Lewis acid. Tapi kat sini bila saya cakap extra meaning dia dah hasilkan ikatan. So you can see here from from H2O and ammonia. Bila saya cakap extra meaning dia tak terlibat dalam ikatan. So ada elektron yang terlibat dalam ikatan kat sini. So this is involved in a bond. Tapi ini tidak. Ini pun tidak. Itu saya maksud by extra. Ammonia pun sama. Sini ada terlibat dalam ikatan, involved in a bond, tapi ini tidak. So this is extra. Tapi untuk silver plus, Ag plus, all of them are not involved in a bond because it is an ion, Ag plus. So dia boleh accept ataupun donate dia punya lone pair of electron. But according to all the options yang ada tadi, this is the most likely yang akan terima electron pair compared to all of this. Ini tak boleh terima dah, dia dah stabil. Okay, this is stabil. Stable. So it cannot accept more lone pair. This is also the same. Stable. Cannot accept any more lone pair. Macam mana saya tahu dia stable? It is because dia punya H plus, dia punya hydrogen dalam H2O ni dah complete. Dia dah ada 2 elektron dalam dia punya orbital. This hydrogen also the same. Oxygen dah obey octet rule. Dia dah ada 8 elektron. 1, 2, 3, 4, 5, 6, 7 dan 8. So it is stable. Ini pun sama untuk ammonia. All the hydrogens ada 2 elektron. Nitrogen ada 8. 1, 2, 3, 4, 5, 6, 7 dan 8. So that's why it is stable. Tapi Ag plus not as stable. Dia tak ada ikatan and dia ada banyak elektron and charge dia also positive, meaning dia boleh terima lagi elektron. Itu yang dimaksudkan dengan positif. Okay, so silver dia terletak the grouping in the periodic table of elements adalah dalam transition metal. That means dia also duduk dalam block D. So dalam block D dia boleh hold as much as 10 electron. Silver electron in valence shell of silver. So tengok sini dia duduk dalam orbital D. So dalam orbital D dia boleh hold as much as 10 elektron. So that's why kalaulah dia dalam dah ada lebih daripada 8 pun dia masih lagi positif. Okay? Maybe that's not a good example juga lah untuk bagi pada kamu untuk differentiate between Lewis acid and base. Because banyak layer of explanation. Tengok ada lagi satu soalan lepas ni. Oh my god, that's the last one. Okay. Kita akan tengok lagi another example dalam another quiz this lesson. So in that lesson, the idea is you should be able to know and differentiate between the 3 types of definition of acid and base. Kita ada Arrhenius, Bronsted and Lowry dan juga Lewis. Okay, remember untuk Arrhenius, they define acid and bases as something yang ada H and ada OH. So kalau dia dissociate, kalau sesuatu bahan yang ada hydrogen dan dia dissociate menghasilkan hydrogen ion, that is acid. Kalau dia dissociate menghasilkan OH minus ion, dia adalah base. Astaga. Why are you like this? Bila saya buat pasang this app dengan Microsoft Teams, always ada problem. Okay, macam saya cakap tadi, kita akan proceed with another quizzes lesson. So let me get the link sementara fix this bug. Betul. Okay, let's try to do this. Okay, so macam saya cakap tadi, ada more questions yang kita boleh address. So kita akan discuss dekat sini. Start a live quiz. So please join this one. Bila dah ada link, saya akan share link. So this is a quiz, bukan pop quiz. Meaning saya takkan ambil kira ni as your grade. Cuma kamu buatlah, kamu jawab. Like it is a quiz. Kita akan discuss the answers when you are finished. So saya akan share the link kat dalam chat room ataupun kamu boleh join pakai this code je. Go to joinmyquiz.com and enter the code. Slow lah. Banyak senang buka. Okay, saya dah post the link dekat dalam chat room. Okay, ramai dah join. Boleh pula. Uh,
Hello, sir.
Ya,
Sir, boleh tanya kah?
boleh.
Apa ni record kelas yang untuk yang record ni kan saya ada upload PGITL kah?
Belum lagi. Saya dah a couple of 3 kelas yang lepas saya belum upload lagi. Saya ada satu link kan dekat dalam ITEL tu, recorded class kan. Nanti saya dah attach the playlist, nanti saya upload masuk dalam playlist tu later today.
Okay, sir. Thank you.
And lastly, apa tadi? Was it? Let's see this. Oh, banyaknya. Which one is it? Okay. Okay, baru 9 orang join. Selebihnya ada problem ke? Ke saya punya ni yang dah lembab. Let me refresh my browser. Okay, kita mula dulu dengan 10 orang ni. Dan selebihnya boleh join afterwards. Okay, most of you dah nak habis. Sharmila and Sharifah still working on their problems. Hopefully in 5 more minutes boleh habis. Bila dah selesai nanti kita akan discuss. So from here saya boleh nampak lah. Mana the accuracy? Okay, so only 54% accuracy. So maksudnya only half of you got half of the questions right. So that's not that good. So saya boleh nampak kat sini mana soalan yang kamu macam tak faham, ramai yang dapat salah. So kita akan address one by one, especially this one ni. 2 orang saja betul. Ini 3 orang saja betul. So I can see bagaimana yang kamu tak faham. Ini 2 orang saja betul. Tengok balik nanti. So kalau lagi ramai orang jawab, lagilah saya dapat get an idea how well you understood apa yang kita dah go over tadi. So that's why saya nak ramai-ramai boleh join. So kat sini ada 11 orang saja. So hopefully that's enough lah. Okay, so kita akan tengok berapa ramai. Hopefully kamu get a better understanding lepas kita discuss ni. All right, so everyone is done. Thank you for participating. Yes, I want to end the quiz. So congrats to Pavitra, Aniza and Chuan. You got the highest, the top 3 marks. Sekarang kita nak review. Okay, so let's take a look at question 1. Soalan ni, kenapa dia tulis kosong-kosong? Questions. Tengok pada soalan. Dah hang lah. Never mind. Okay, so soalan nombor 1. According to Bronsted and Lowry acid-base theory, an acid adalah apa? So jawapannya adalah a proton donor, sesuatu bahan yang menderma proton. So that's why saya tulis kat sini. Bronsted acid, they donate H+ ion. So kamu maybe tak familiar with the term proton. So H+, sometimes in chemistry kita akan panggil dia proton. Okay, proton. So why? Kat sini there's an interesting story, explanation. Okay, there's an interesting explanation kenapa hydrogen kita panggil sebagai proton. So let's explore that. Kita go back to chapter 1. Kita tahu hydrogen is an atom and there ada nucleus. And inside a hydrogen nucleus, kita tahu ada neutron dan juga ada proton. Let me draw back. This is the nucleus. Nucleus of hydrogen. So inside this nucleus, kita ada satu proton dan satu neutron. Okay? And ada satu elektron berkeliaran dekat luar ni. Moving around freely. So the thing with hydrogen, bila dia mendermakan dia punya elektron, okay, bila dia form jadi ion, that means bila dia jadi H+. Okay, bila dia jadi H+, meaning dia dah kehilangan. Kita dah kehilangan this electron here. What color yang contrast? So this electron, we lost it. Okay, it is no longer in the atom. Katakanlah dia pergi donate to another element, another atom. So now what is left adalah kita go to this lah. Jadi H+, that means apa yang tinggal hanyalah a nucleus with proton and juga neutron. So the mass of this atom, of this ion right now adalah just the proton. So that's why kita panggil a H plus ion sebagai proton. Kerana dia tidak ada electron. We have eliminated electron. Okay, so that's why sometimes in chemistry kita panggil H plus ion, hydrogen ion sebagai proton. So we use it interchangeably. Hydrogen ion equals to proton. So dalam soalan tadi tu, I figure ramai orang jawab salah, maybe sebab kamu tak tahu proton adalah also H plus ion. So sesiapa yang donate proton, that means dia donate H plus ion, hydrogen ion. Next question, according to Arrhenius acid-base theory, an acid pula adalah, jawapan yang betul adalah is a substance that produces H plus in water. So go back to this, Arrhenius theory, acid bila dia dissociate, meaning bila dia larut dalam air. So by definition, Arrhenius ni, the only define bahan yang dissolve, itu limitation, dissolve in water only, H2O only. So dalam Bronsted-Lowry and juga Lewis ni, they cover all other solvents. All solvents. So pada zaman Arrhenius ni, most solutions, most chemical solutions are prepared in H2O only. Tapi as we move forward, as we develop our theory lagi dengan lebih lanjut, kita tahu some solutions are better kalau dia dilarutkan menggunakan solution solvent yang lain. Okay, contohnya macam alkohol ke, this includes like ethanol ke methanol, example, acetone, hexane. So all of these could be solvents also. Alright, itu adalah kelemahan Arrhenius theory. What was I talking about tadi? So Arrhenius theory, untuk Arrhenius acid, bila it dissolve in water, it produces hydrogen ion. Bila it dissolves in water, it dissociate OH ion, OH minus, dia adalah sejenis Arrhenius base. Next question. Which reactant in the following equation is acting as a Bronsted-Lowry acid? So dia bagi satu chemical equation kat sini. Ammonia tambah water. So basically it means we prepare a solution of ammonia in water. So this will produce, bila ammonia tu larut dalam air, dia akan menghasilkan ammonium. Ammonium is NH4 plus and also hydroxy ion. So let's take a look. Let me draw this. Let me write this chemical equation down. So kita tengok in this ammonia solution, NH3 tambah dengan H2O. Dia akan hasilkan ammonium NH4 plus tambah OH minus. So some of you might like get lost, confused. Macam mana kalaulah saya give you a problem. Katakanlah I give you a problem. What happens? Write down the chemical equation, balance the chemical equation bila ammonia tambah dengan air, bila kita larutkan ammonia dalam water. So what is A and what is B? So the first step, okay, this is like not the problem dalam soalan quizzes tadi. So this is a different side of it, a side note. My tip is kalau kamu nak tahu what is product A and B, you write down the dissociation. Kamu pecahkan all these two molecules. So untuk NH3, dia akan hasilkan apa nama? No, kita akan cakap acid and bases. My bad. Astaga. Astaghfirullahaladzim. Go back. So, sorry. So kat sini kita nak tengok siapakah soalan tadi, siapakah acid and base kan? My bad, my bad. Acting as a Bronsted-Lowry acid. So kita tengok dekat sini definition of Bronsted-Lowry acid adalah something that donate H plus ion. Okay, so this is definition of acid. something that donate H plus ion. So macam mana kita nak tahu siapa yang donate? Kita tengok to this, we look at this chemical equation and it is given in this question tadi. This is substance A and this is substance B and this is C and D. This is the conjugate acids and bases. So kat sini kita tengok A and B and kita tengok pada C and D. What happens? What changes from A and B to C and D? Kamu boleh nampak, kamu tengok pada ammonia for example. If you take a look at ammonia, you can see NH3 pada asalnya dia ada 1 atom nitrogen dan 3 atom hydrogen. Okay, you count the number of hydrogen. You bukan count, you be aware of the number of hydrogen. Bila nak define Bronsted-Lowry acid and bases, you be aware of the punya number of hydrogens of each of the substances. Because definition of Bronsted-Lowry of acid and base bergantung kepada pergerakan H plus ion. So kat sini pada asalnya dia ada 3 saja bilangan hydrogen, 3 only. Tapi bila dia at the end product, dia ada 4. So what changes here adalah the addition of one proton, 1 H. So that means ammonia ni dia accept H plus. Dari mana dia terima? Daripada H2O. So you can verify this. Betul ke datang daripada H2O? So tengok pada H2O asalnya ada 2 hydrogen. In the end dia hanya ada 1. So the amount of hydrogen is now reduced. Kenapa reduce? Because dia donate dia punya H plus. Okay, so you remember bila ammonia bercampur, ammonia in dalam room temperature dia adalah liquid. H2O is also liquid. So bila kita mix these two together, what will happen adalah dia akan dissociate macam kita cakap tadi. And H2 minus dan juga H plus. This is what will happen. Dia akan dissociate. Ini pun sama. Dia akan dissociate menjadi OH minus dan juga H plus. Ini yang saya cuba nak terangkan tadi. So what will happen here is, siapa yang lebih mudah untuk donate dia punya H plus, that is, kita akan tengok dalam topik strength of acid and base tadi. So according to this, H2O is a stronger base. So kita akan tengok kejap lagi in our next second slot nanti kenapa H2O is a stronger base. So kat sini kita boleh conclude that H ni yang akan donate dia punya, H2O yang akan donate dia punya hydrogen, H plus. So what will happen is H ni akan go to this one. So dia akan form NH4 plus. Dia tak akan donate dia punya. So ni bercantum balik semula in the end. So dia ada 4 bilangan hydrogen. So that's why hydrogen in the end dia remain bentuk macam ini. Okay, so in this case kita dah dapati H2O donate dia punya H plus and NH3 is the one that accept. So that's why by definition Bronsted-Lowry acid dia adalah somebody that donate dia punya H plus and then the base is somebody that accept dia punya H plus. Next question, sulfuric acid HSO4 minus tambah H2O produces hydronium ion H3O plus dan juga sulfate ion SO4 2 minus. Identify the Bronsted-Lowry acid in the above reaction. So remember, Bronsted-Lowry by definition is something that donate dia punya H plus. So kita tengok kat sini siapa yang donate. Mana dia? Kita tengok balik, we count with the number of hydrogen. We look at the before and after the reaction. So HSO4 minus pada asalnya ada 1 hydrogen, tapi in the end there's no more hydrogen. So that means dia donate dia punya hydrogen. So that makes HSO4 minus adalah the Bronsted-Lowry acid. So that's why the answer adalah HSO4 minus. Okay, once you understood the main principle of the definition, kamu akan dapat tangkap dengan mudah lah. The main principle of Bronsted and Lowry adalah pergerakan hydrogen ion. So kalau kamu tengok pergerakan hydrogen ion in this case, dia bergerak daripada HSO4 minus, dia pergi kepada H2O. So that makes HSO4 minus adalah acid. How do we know that it moves from HSO4 minus to H2O? Kita tengok pada in the chemical equation, tengok on the right hand side. Macam saya cakap tadi, HSO4 asalnya ada satu bilangan hidrogen, tapi in the end, dia tak ada hidrogen. So that means hidrogen dah bergerak from HSO4 minus kepada H2O. Okay, make sure you understand the main principle first, pergerakan hydrogen ion untuk Bronsted and Lowry theory. Next one, using this reaction, which species is the conjugate base? So dalam when we're talking about acid and bases, kita sometimes use the word species untuk panggil this ni lah, these substances. Okay, CO2, CO3 carbonate ion, H2O, H3O, C minus, HCO3 minus, or H. These are all species. So using the above reaction, which species is the conjugate base? So conjugate base means something that is the kehilangan hydrogen. Okay, so in Bronsted and Lowry, conjugate acid means a substance that is accepted. Mana my whiteboard? In Bronsted and Lowry, theory, conjugate acid is something that menerima, accepted H+. So that makes a conjugate base something that lost H+. Okay, so to answer that question tadi, which species is the conjugate base? Kamu kena identify species yang kehilangan H. So tengok pada the left hand side of this equation. So CO32 minus tak ada hydrogen. Dan sini ada hydrogen. So the one thing that could lose hydrogen adalah H2O. So H2O bila dia lose one hydrogen, dia akan menjadi OH minus. So that makes OH minus, hydroxy ion ni adalah the conjugate base. Okay, remember, conjugate base is a species that has lost and a proton, sorry. I know there's a lot of definition kat sini yang kamu kena hafal. Tapi that's why saya cakap tadi, kalau kamu understand the main principle, you don't necessarily need to hafal. Sebab bila kamu faham untuk Bronsted and Lowry theory, pergerakan hydrogen. Once you understood the main thing that defines acid and bases, conjugate acid and bases dalam Bronsted and Lowry theory adalah pergerakan hydrogen. Once you see the pattern, the movement of hydrogen that is define all of this theory untuk Bronsted and Lowry, you don't necessarily need to hafal. So dalam this question, a substance that remains when a base has accepted an H+ ion adalah a conjugate acid. Okay, remember tadi saya tulis, a conjugate acid adalah somebody that has accepted H+. A species yang telah menerima H+. Rina dekat saya, excuse me. Asalkan tekak sekejap. Okay, next question. Okay, another chemical equation. H3O minus, HCO3 minus, banyak kali saya silap sebut ni. HCO3 minus tambah OH reacted with each other and they produces H2O, water dan carbonate ion. So dia cakap kat sini, choose the conjugate acid of OH. So the conjugate acid meaning dia akan terima hydrogen. Okay, remember, bila dia cakap tentang conjugate acid, that means a substance, a species yang telah menerima hydrogen. So kat sini kalau OH ni terima hydrogen, you tambah H ya, dia akan jadi H2. Okay? If you have any questions, just stop me and tanya. Next one, another chemical equation. Nitric acid tambah water. So we dissolve nitric acid in water. HNO3 adalah nitric acid. Kita larutkan dia dalam air, kita akan dapat hydronium ion, which is H3O+ dan juga nitrous ion, NO3-. So choose the conjugate base untuk HNO3. So kalau kita nak cakap tentang conjugate base, that means a species yang sudah kehilangan H. So in this case, tolaklah H from HNO3 tu, jadilah NO3-. So from the options, jawapannya adalah the last one, NO3-. True or false, all areneous acids are also Bronsted-Lowry acid. So the answer is true. Okay, semua. So this is a bit of a thinker. All areneous. So kalau kita buat satu Venn diagram, so katakanlah ini adalah, tak cukup lah, kecil sangat circle. So this is areneous acid. That means a substance that produces H+ ion. So untuk Bronsted and Lowry, kita tengok by definition tadi. Mana dia? Bronsted and Lowry. Bronsted and Lowry theory, acid adalah something that donate H+. So samalah. Tetapi Bronsted and Lowry tak limit dia punya definition of acid kepada water saja. So that means dia punya scope is bigger. Dia punya definition is bigger. So apa nama? Bronsted and Lowry, saya tulis BL lah. Bronsted and Lowry's acid. Acid also something that produces H+, but also it covers, penting kat sini, the distinction antara Bronsted and Lowry and areneous, all solvents. Untuk areneous, in water only. Itu perbezaan dia. That's why saya cakap Bronsted and Lowry ni mengembangkan the scope of definition of acid and bases. Untuk Bronsted and Lowry, they cover all solvent. Untuk areneous acid, they cover only substances yang larut dalam air sahaja. So the answer to that question tadi betul lah. All areneous acid adalah Bronsted and Lowry's acid, but not all Bronsted and Lowry's acid adalah areneous acid. Sikit lagi ya. Habis kita discuss ni, you have your 30-minute break. Which of the following substances is both Bronsted-Lowry base and also an areneous base? So kat sini kita tengok by definition something that can menghasilkan OH- ion. You see, tengok balik the definition of Bronsted and Lowry base dan juga areneous base. Let me go back. Areneous base is something that produces OH-. What was the question again? Kenapa saya dah macam blur? Which of the process is both a Bronsted base and an areneous base? Okay, dia boleh terima. So in this case, kita nak tengok sesuatu bahan yang boleh buat kedua-duanya. Sesuatu bahan yang boleh terima, yang boleh menghasilkan OH- ion, dan sesuatu bahan yang boleh accept H+. So all of the options tadi tu, untuk lithium ion pula, lithium hydroxide, kan, that was the substance kan, lithium hydroxide aqueous, correct. So untuk lithium hydroxide, bila dia dissolve in water, dia boleh dissociate menghasilkan lithium plus dan juga OH-. So by definition, bila dia boleh hasilkan OH- ion ni, because it can produce this, that means dia adalah sejenis areneous base. Kita tengok in the second condition, kalau dia boleh terima lithium OH. Mana dia? Dia tambah H+. Okay, because the definition of Bronsted and Lowry base adalah something that can accept H+. So in this case, kalau lithium hydroxide LiOH tambah H+, dia boleh menghasilkan a lithium ion. Lithium OH. 2. Okay, so this is basically, this is a side note. This is how our devices punya battery, lithium ion battery. If you take a look, apa nama lithium ion batteries. So this is how, kalau kamu take a look at your phones, your laptop right now, most of your power banks, most of the batteries adalah lithium ion batteries. So what does that mean adalah the battery akan menghasilkan lithium ion, Li plus dan juga OH minus. So bila kita charge, bila kita guna our devices, the amount of lithium akan menurun. Lithium ion akan menurun. So bila kita charge dia, kita akan hasilkan satu tindak balas, kita akan tambah hydrogen to that substance, to that lithium ion tadi tu. So dia akan convert balik jadi lithium OH2 minus, and then dia boleh dissociate lagi. Dissociate lagi menghasilkan lebih banyak lithium ion. So dia akan increase bila kita charge. Okay, so that's a side note how our lithium ion batteries work. Kita just bila dah habis guna lithium, kita akan generate more lithium bila kita charge. So to answer that question tadi, bila kita add hydrogen to our lithium, that means dia boleh accept. So when it accept H+, that means dia adalah Bronsted and Lowry's base. Untuk bahan-bahan yang lain, dia tak boleh buat dua-dua benda ni. So for example, kita tengok NH3. NH3 kita boleh eliminate siap-siap because dia tak ada OH. Bila dia dissociate in water, dia tak boleh menghasilkan OH minus. So it is not an arrhenius base. The same goes for HCl. Dia tak ada OH. Bila di dissociate, tak boleh produce hydroxy ion. Cancel. HCl is also the same. So bila it is not an arrhenius base, kita boleh boleh cancel dia terus. Kita tak perlu tengok pun whether it is a Bronsted-Lowry base ataupun tidak. Okay, because that is the simpler one between the two untuk kita kenal pasti. Okay, next question. Ada lagi 4 question Which of the, oh no, ini saya tak cover dalam kita punya syllabus. Never mind, sorry we skip this one, saya tak nak bagi kamu more information. Hydronium ion is H3O+. Okay, it's just water with one more hydrogen. Itu nama dia. Which substance is arrhenius base? Dia adalah sesuatu bahan yang boleh menghasilkan hydroxy ion. So in this case, KOH is the most yang boleh menghasilkan hydroxy ion dengan sepenuhnya. So kenapa CH3OH bukan arrhenius base? Bila kita bandingkan dengan KOH, this is because KOH is better, is a stronger arrhenius base. Dia lebih dia lebih mudah untuk menghasilkan hydroxy ion berbanding dengan CH3OH minus. So it's a bit tricky here. Okay, it's kind of cheating lah because kamu tak belajar lagi tentang strength of acid and bases. Okay, the answer to this is because this is a weaker arrhenius base. It is least likely to produce OH minus ion. Ini lagi tinggi chance untuk produce OH minus ion. Kita akan tengok our lesson after this adalah the strength of acid and bases. And your third last question, the conjugate acid for NH3 for ammonia adalah NH4+. Remember, conjugate acid is something that terima H+. So tambahlah satu H pada NH3 ni, jadilah NH4+. According to Arrhenius acid and base theory, a base is something that produces hydroxy ion in water. And last question, according to Bronsted and Lowry acid and base theory, a base adalah something that accepts a proton. So most of the question yang kat ujung-ujung ni adalah depending on you understanding ataupun kamu hafal the pergerakan of the pergerakan of the hydrogen, pergerakan what it produces, ion, hydrogen ion ke, H plus ke, OH minus. Okay, so that's it. That's a quiz. Now we have our 30-minute break. Kita akan resume our class pada pukul 11.10 lah. Okay, cukup 30 minit. Dan harapkan lagi 2 minit tu. So, siapa-siapa yang ada kat campus boleh get your lunch. Yang kat rumah tu bolehlah rehat saat. Maybe get your brunch or something. Okay, so see you in 30 minutes 11.10. Kita akan buat another quizzes lesson.
Okay, sir.
Okay, we're back. Semua standby, semua dah ready. Okay, untuk the last slot ni kita akan buat about like 30-40 minutes. Hopefully kita boleh habis by then. Kita boleh wrap up. Kita just nak discuss. Patutnya saya share ni before. Where is it? Kita nak discuss about the strength of acids and bases. So we're going to do another quizzes lesson again. Dalam this subtopic, kita akan discuss how do we determine the strength of an acid ataupun the strength of a base. So please join again once the link. Okay, so please enter the join this with the code. It's a bit slow untuk saya share dalam chat, so please join guna ni guna code. Oh, laju boleh. Okay, so dia tak lag dah. So saya share the link dalam chat room. So boleh go to chat room and then just click on it and join. Oh, saya tak share screen, that's why kamu tak nampak. Oh, my bad. Hello, testing, kamu boleh dengar saya tak?
Tak boleh, sir.
Tak boleh. Hello, testing. Tapi screen saya kamu nampak ada... Oh, sorry. Kamu nampak quizzes ke kamu nampak a white page?
White page. White page, sorry.
Yes, something dah hang lah ni. Let me unshare and share it again. Okay, I think that's better. I can see here from my phone. Wait a minute. Ya, saya tak boleh share. Hello, testing. Am I still here? Hello, testing. One minute, I'm trying to leaving the ni. Saya akan join balik. Saya nak leave this meeting and then saya join balik semula. Sorry ya. Hello, testing. Am I still in? Hello, testing. Hello, testing. Still in. Hello, testing. Hello, testing. Hello, testing. Hey, this is a waste. Hello, testing. Can you hear me?
Can, sir.
Alright, thank
Boleh,
you.
sir.
Sorry.
Boleh, sir.
Leceh sikit. Okay, sorry. Dah on for too long. Okay, hari ni our last slot of our semester, kita akan tengok kita punya last subtopic iaitu strength of acid and bases. Tapi sad, let me share my screen. Boleh ke tak boleh? Tadi ada problem kat sini. Okay, so boleh nampak. Alright, so strength of acid and bases. So dalam this topic kita nak discuss how can we determine sesuatu acid tu a strong acid ataupun a weak acid, ataupun sesuatu base tu whether it is strong or it is a weak base. So to understand that, that's why it is important kita tahu dulu, we understand how do we define all of these acid and bases. Okay, macam kita dah tengok tadi, pagi tadi, there are three definitions of acid and bases. Ada three theories that defines acid and bases. Kita ada Arrhenius, Bronsted and Lowry, and Lewis. And all three of them define acid and bases a bit different from one another. And some is expand the definition. So dalam this slide, saya kata strength of acid and base refers to the extent to which an acid or base dissociates in water and has no impact on the concentration or amount of the solution. Kita tengok pada kebolehan sesuatu bahan itu untuk menghasilkan ion dalam larutan. Kita tak tengok pada dia punya kepekatan, tapi kita tengok pada kebolehan dia untuk menghasilkan ion. Okay, that's the keyword. Kebolehan sesuatu bahan untuk menghasilkan ion. Ion apa? It depends on the kinds of bases that we are defining. So a small amount of acid and base can still be strong. So likewise, a large amount of acid and base can still be weak. So this means the elaborate further on this sentence here. Dia tak bergantung kepada kepekatan sesuatu larutan tu. Kalau sesuatu bahan tu, maybe dia punya concentration tinggi, tapi it can still be a weak base. Because we define the strength of an acid and base pada kebolehan bahan itu untuk menghasilkan ion in air, ion in water. So what is a strong acid? So it is a substance that ionizes completely, menghasilkan ion, hydronium ion ataupun H+ ion dengan sepenuhnya. So the key word here is sepenuhnya, completely. So contohnya nitric acid, HNO3, bila dia larut dalam air, dia akan menghasilkan hydronium ion, H3O+, dan juga NO3-. So a new way arrow here is used since the reaction is complete. So dalam this tindak balas kimia, persamaan kimia ni, bila dia cakap tentang a new way arrow ni, it means this one. Sorry, a new way pula. A one-way arrow. My God, saya punya bacaan pun dah apa dah. A one-way arrow. So you have to understand here, a chemical reaction can go both ways sometimes. Okay, so satu bahan tu bila dah menghasilkan, bila bahan A dan bahan B bertindak balas, dia boleh menghasilkan bahan C dan bahan D. But sometimes, under certain conditions, bahan C dan bahan D itu boleh menghasilkan bahan A dan B balik semula. So that's the thing that you have to know before we go through this. So that's why dia kata kat sini, a one-way arrow is used, meaning the reaction is complete. Meaning dia tidak akan menghasilkan the reactant balik semula. So dalam tindak balas persamaan kimia ni, this tindak balas dia HNO3, nitric acid dan water. Bila dia bertindak balas, dia akan menghasilkan hydronium ion H3O+ dan juga nitrous ion NO-. So this one-way arrow dictates that this hydronium ion dan nitrous ion ni tidak akan menghasilkan nitric acid dan water balik semula. So this means it ionizes completely, dengan sepenuhnya. So that's why dia kata a one-way arrow dictates the reaction is complete. All of the nitric acid molecule, all of the HNO3 molecule break apart to form hydronium ion dan juga nitrous ion, NO3 ion. Thus, all of the reactants are converted to form the products. That is the definition of a strong acid. It ionizes completely. That's why on the first point here, the bold, the whole sentence, a substance that ionizes completely. Menghasilkan ion dengan sepenuhnya. Ion apa? In this case, hydronium dan juga hydrogen ion. Hydronium, H3O+, dan juga H+ ion. Examples of strong acid adalah, there are 7 that probably best that you memorize. Okay, kita ada hydrochloric acid, hydrobromic acid, hydrogen iodide, nitric acid, sulfuric acid, hydrochloric acid dan juga hydrochloric acid. Okay, so HClO4, HCl, H2SO4, HNO3, Hi, HBr, HCl. These are all substances dan bila dia larut dalam air, dia akan menghasilkan H+ ion dengan sepenuhnya ataupun hydronium ion dengan sepenuhnya. Tapi ada banyak lagi asid yang lain. Ada banyak lagi strong acid yang lain. So how do you identify that? Kamu kena tahu whether it ionizes completely ataupun tidak. Ada cara dia. There's a mathematical equation, a mathematical sense of this definition. But for now, just focus on these 3. Maybe kalau kamu sambung study in your degree nanti, kita boleh tengok that mathematical part of the equation. Kita boleh calculate whether acid itu adalah strong ataupun weak. Quantify it. Weak acid pula adalah an acid, a substance that ionizes only partially. It ionizes partially to produce hydronium and hydrogen ion. A small amount of ion saja terhasil. Contohnya macam acetic acid. Yes, acetic acid. This is acetic acid. Okay, bila dia larut dalam air, dia akan menghasilkan H3O+ dan this ion C2H3O2- ion. But you can see here, there ada two-way arrow. So two-way arrow means the reaction is not complete. So after a while, because this structure is not stable, the product yang dihasilkan tu tidak stabil. So bila tak stabil, dia akan try to find its way back to stability. So how to find its way back to stability adalah dengan menghasilkan bahan-bahan ni balik semula. So pada asalnya you can see here, this substance here akan donate hydrogen pada H2O. That's why dia akan hasilkan H3O+ dan juga this ion. Tapi macam saya cakap tadi, dia tak stabil. So because of that instability, dia akan hydronium ion ni akan donate dia punya hydrogen balik semula to this ion, thus producing dia punya form yang asal. So a two-way arrow here is used since this reaction is not complete, but instead it consists an equilibrium, a mixture of acetic acid, hydronium ion dan juga acetic acid ion. Okay, so my tip for you is macam mana kalau kamu nak identify without using that mathematical equation. So my tip is, kita tengok dekat sini. In the strong acid equation tadi, kita tengok in this equation, kamu tengok on the hydrogen. Okay, ataupun tengok pada hydronium ion. So in this case, pada acid ni, this is the acid that we are talking about. Dia ada satu atom hydrogen. And bila dia bertindak balas dengan air, bila dia larut dalam air, all the hydrogen atoms of nitric acid is used, digunakan sepenuhnya untuk menghasilkan hydronium ion. So in the end, there's no more hydrogen. So that is the definition of it ionizes completely. All the hydrogens in the acid is used. Kesemua bilangan atom hidrogen dalam nitric acid ni, dalam HNO3 ni digunakan dengan sepenuhnya. That's not an accurate definition because kalau kita tengok another example dalam acid yang lain maybe tak benar. Tapi in the sense, in general, a quick tip, bagaimana cara dengan cepat untuk kamu identify acid tu strong ataupun weak, tengok pada bilangan hidrogen dalam acid tu. So, kalau semua bilangan hidrogen digunakan That means that is a strong acid. So how do you know? You have to know how to write this equation. So kalau this hydrogen dissociate, menghasilkan hydrogen ion and it donates that hydrogen to H2O plus, then dia menghasilkan hydronium ion. So that makes nitric acid a strong acid. So kita boleh apply this logic to all the other example yang strong acid tadi tu. HCl, dia ada satu saja hydrogen. So kalau dia larut dalam air, dia akan menggunakan all of its hydrogen. HBr also the same. HI also the same. H2SO4 is also the same. Walaupun dia ada dua hydrogen, tapi both of them kalau kita write the equation, dia akan menghasilkan water. Kalau kita balance the equation. Same for this one and same for this one. So the keyword is ionize, use completely. And also it helps kalau kamu boleh tulis the chemical equation. So kalau weak acid, dia only ionizes partially. So let's take a look at this. Kita tengok kat sini. There's a lot of hydrogens here. There are 3 hydrogens. CH2 dan H3O2. Sorry, ada 4 hydrogens. Tapi kita tengok in the end, only one of the hydrogen is used. Okay, only one is used to produce H3O+. Lagi 3 ada, it's still here. So it ionizes only a small extent sahaja, tidak completely, only partially. Okay, that's a small tip, that's a quick tip for you. Macam mana kamu nak tahu whether an acid is strong or weak. Alright? So equilibrium lies to the left since most of the acid molecules have not ionized. So this is maksudnya kat sini apa yang dia kata kat sini equilibrium lies to the left, maksudnya bila this tindak balas terhasil tak banyak ion yang akan terhasil sebab ada banyak lagi hidrogen yang tak digunakan dekat sini. So most of the time kalau dalam larutan ni bila kamu ambil acetic acid, kamu larutkan dia dalam air, most of the time ion ni tidak akan ada dengan banyak. Yang ada dengan banyak adalah it exists like this dalam bentuk ni. Yeah, so example adalah ethanoic acid which is cuka ataupun citric acid yang ada dalam buah citrus. So examples of common weak acid adalah sedemikian. HF, HNO2, HCN, H3PO4, H3CO3, hydrogen carbonate, carboxylic acid, banyaklah kat sini. Okay. So saya tahu kat sini ada kat sini saya tulis HF, ada satu saja hydrogen tapi kenapa partially? So it's best kalau kamu boleh tulis the chemical equation. Tapi for now it's probably best kalau kamu hafal hafal yang ini saja. The only way that we can determine whether this is weak or strong adalah by using the equilibrium equation which is in the lecture notes, tapi because it's too complicated, so saya tak nak tambah dekat sini. This is the math part yang saya mention tadi. This is how we determine sama ada that value is that acid is weak ataupun strong. There's an equation, there's a chemical equation. So this is the formula yang kita guna. So there's a concentration untuk all of these species HP, H2O, H3O plus dan B minus. So kita isi dia punya concentration kat sini, cari a value of Kc dan Ka. So if the value is a certain amount, it is weak. If it's a certain amount, it is strong. Okay, so don't worry kalau saya tak elaborate dengan lebih lanjut dalam kelas. That means dalam your test nanti tak akan ada ni lah. Tak akan ada soalan yang lebih. It will not be fair. Okay, so for now, saya nak minta kamu just basically hafal dekat sini the examples of the weak acid and juga the strong acids. Okay, kenapa kosong? Do you see the points, the bullet points here? Okay, is that a error? Okay, strong base pula. This is a substance that ionizes completely in water to form OH minus ion. So kamu boleh nampak dekat sini, kita punya definition of strong and weak acid and bases, kita focus on Arrhenius theory. Okay, bahan-bahan yang larut dalam air menghasilkan hydrogen ion dan juga hydroxy ion. So untuk strong base, dia adalah bahan-bahan yang larut sepenuhnya. Bukan larut, menghasilkan ion, hydroxy ion dengan sepenuhnya dalam air. So contohnya macam sodium hydroxide, NaOH. So it ionizes completely producing hydroxy ion. So it goes to completion meaning dia tak akan menghasilkan sodium hydroxide balik semula. So that means kalau a weak base, dia adalah bahan yang only partially produce hydroxy ion. So these are examples of strong bases: lithium hydroxide, sodium hydroxide, potassium hydroxide. Most of the hydroxides adalah strong bases. So it is best that you memorize ada 8 strong base ni. So kat sini dia tulis group 1A and 2A, maksudnya hydroxide bases. Lithium, Na, potassium, K ni, rubidium, cesium, calcium, barium dan Sr ni adalah elemen-elemen dalam grup 1 dan grup 2 dalam table, periodic table of elements. So most of the salts, most of the hydroxide of these two elements, of the elements from these two group adalah a strong base. So kalau weak base pula dia adalah sama macam the definition of weak acid, it only ionizes a small extent only, partially. So if you write this chemical equation, kalau saya tulis, I give you a problem dalam test nanti, saya tulis this chemical equation, it goes both ways, front and back. That means the base ataupun the acid dalam tu adalah weak. So in this case, siapa kat sini? Ammonia adalah a weak base. So how do we measure the strength? This can be determined by using pH scale. Macam saya cakap tadi, kalau acid, 1 dan 2 tu adalah strong acid, 5 dan 6 adalah weak. Alkali ataupun base pula, anything closer to 7 is strong, is weak. Kalau closer to the 13 and 14, itu adalah a strong alkaline, a strong base. So what is buffer? So buffer adalah a solution yang susah untuk kita ubah dia punya pH. So weak acid and bases can be used to make buffer solution. A buffer solution, the definition is a solution that is resistant to large changes in pH and so are added to solutions such as medicines, ubat-ubat yang kita hasilkan to make them more stable. Okay, so ubat-ubat yang kita hasilkan dalam dekat kilang-kilang ubat tu, most of them bila dimakan dalam badan, bila kita makan, dia masuk dalam badan kita, dia react as a buffer solution, meaning dia tak akan ubah kita punya the pH of our gastric juice perut kita tu. So it does not disrupt the kita punya body, and also dia boleh larut dengan baik, dengan cepat. Okay, a good pharmaceutical drug adalah ubat yang mudah larut dalam badan kita sebab lebih cepat. Kalau dia lebih cepat larut dalam badan, lebih cepatlah dia bertindak balas. So buffers can be prepared by mixing a weak acid and its salt or a weak base and its salt. So this is how you make a buffer solution, the importance of making or understanding the strength of acid and bases. Because the application in pharmacy adalah kita buat drugs, kita buat pharmaceutical drugs by applying the weak base and the weak acid dalam ubat. This is because a buffer can react with both an acid and a base, and its pH remains relatively constant. Tak mudah berubah. Okay, remember the definition of a buffer. A buffer solution is a substance that is resistant to large changes in pH. Dia tak mudah ubah pH dia dengan banyak. Ubah sikit-sikit, tapi tak banyak. So the concentration of acid and base, it is important to understand because from here kita boleh quantify the strength of acid and base. So the pH, the value yang kita dapat tu 1 sampai 6 untuk acid, 7 sampai 14 tu is by us quantifying the concentration of the hydrogen ion. So kat sini dia tulis point number 2, concentration is the amount of solute dissolved in a given amount of solution. So the strength of acid and bases refers to the solute's tendency to form ions in water. So that's why kita belajar the definition. Dalam Arrhenius theory kita belajar the definition of an acid adalah the amount of hydrogen ions. Okay, the ability of a substance to ionize, untuk hasilkan hydrogen ion. The definition of Arrhenius base adalah the ability of a substance to produce hydroxy ion. So in pH, kita measure the amount of ions yang ada dalam sesuatu larutan tu. Kita kalau nak determine the strength of an acid, kita measure the amounts of hydrogen ions. Kalau kita nak cari the strength of a base, kita measure the amounts of hydroxy ions. Jadilah bila kita convert that, kita dapat cari dia punya pH. So that's how we get that pH scale number 1 sampai 6, 7 and then 8 sampai 14. So we cannot assume that a strong acid has a low pH because its concentration also affects pH. So for instance, a dilute solution of hydrochloric acid, which is a strong acid, it can have a pH of 6 because kita dah cairkan, kita dah dilute, the concentration is very, very low. But a concentrated solution of acetic acid can have a pH of 3. So kat sini, kita sangat penting kamu faham the relationship antara the concentration of a substance dengan the concentration of dia punya ion. Okay, dia main peranan. This is a good example to demonstrate that. Walaupun HCl adalah a strong acid sebab kita define the strength of an acid by dia punya kebolehan untuk menghasilkan hydrogen ion. So HCl boleh hasilkan ion H+ dengan sepenuhnya. Tapi kalau kita cairkan dia, dia punya concentration sangat-sangat rendah. Dia punya pH boleh jadi rendah, boleh jadi weak. Boleh jadi 6 dekat sini dia bagi. So kalau acetic acid is a weak acid. Okay, sebab dia tak boleh hasilkan hydrogen ion dengan sepenuhnya. Tapi dia boleh hasilkan bacaan yang tinggi untuk acid kalau kepekatan dia tinggi. So let's try to solve this problem. Which of the following statement is correct about weak base ammonia? So take your time. Ingat balik apa yang saya kata tadi. Okay, so dia kata dah kat sini, ammonia punya ability is a weak base. So it is a weak base. So jawapannya adalah it dissociates partially in water to produce a low concentration of hydroxide ion. Okay, so only like 5% only got it right. That means you don't know what to do with this question. The rest ni, 8 orang ni. So the way for you to tackle this question adalah tengok balik pada soalan dia. Which of the following statements is correct about the weak base ammonia? So dah beritahu dah kamu, sorry. Soalan ni dah beritahu kat kamu the species of ammonia, which is a weak base. So kamu kena figure out in your head a weak base adalah apa. What is the definition of a weak base? Arrhenius theory. The definition adalah kebolehan untuk menghasilkan hydroxy ion separa dengan separa. Dia tak boleh menghasilkan hydroxy ion dengan sepenuhnya. So tengok balik dalam statement ni which one yang paling tepat to that definition yang kamu baru figure out tadi. So the ones yang last kali is the answer because dia kata kat sini it dissociates partially, separa saja in water to produce a low concentration of hydroxide ion. So hydroxide ion adalah OH minus. So the higher the concentration of an acid, the stronger the acid. Is that true? True or false? The higher the concentration, the stronger the acid. Time's up. Jawapannya adalah false. Betul tak? Saya takut saya pun salah. Jawapannya adalah false. Correct. Okay, so half you, more than half got it right. So congrats. So remember the definition. The strength of an acid basically also relies on the ability of its the strength, my bad. The strength of an acid depends solely on the ability to produce H plus ion. Kita tengok pada concentration. Concentration only applies kalau kita nak cakap tentang pH. Okay? So strength of an acid and bases depends on its ability to produce lebih kecilkan sikit, to produce H plus ataupun OH minus ions completely. Completely is the keyword. Okay, so kalau dia boleh hasilkan H plus dan OH minus ion completely, it is a strong acid and base. Kalau dia boleh buat partially, it is a weak acid and base. So kalau kita cakap tentang concentration, that means we are venturing into pH. So pH is influence, dipengaruhi oleh concentration and also by dia punya amount of ions. In this case, H plus dan juga OH minus. Okay, kita tengok pada concentration of the solution dan juga pada the amount of H plus dan OH minus yang ada. So kita kalau nak cakap tentang pH, dua benda yang kita kena consider. Tapi kalau nak cakap pasal the strength of an acid and base, kita tengok pada satu benda saja, kebolehan dia menghasilkan ion-ion ni. Let's go back to the quizzes. Mana ada? There are two types of acid and bases. So this is like okay, jawapannya adalah strong and weak. Okay, strong and weak. Saya tak consider, saya tak cakap pun perkataan sawut dan bitter sepanjang 2 jam, 3 jam kita dalam kelas hari ini. Okay, so dua orang ni, please make sure the two types of acids and bases adalah strong and weak. The difference between a strong and weak acid adalah Okay, so the difference between a strong acid, lambat sangat ada 800 saat, lamanya dia set. So the difference between a strong acid and a weak acid adalah, kita tengok balik the definition. A strong acid dia boleh ionize, menghasilkan hydrogen completely. Kalau a weak acid only partially saja produce H plus ion. So that is the main definition. So the answer adalah strong acid break apart in water. Weak acid stay intact. So what does that mean adalah, that's why saya tulis this chemical equation. This is a strong acid. Mana mouse? So this is strong acid. This is weak acid. So you can see by writing this chemical equation, saya boleh nampak. Okay, saya boleh nampak the ions, the hydrogen ions yang dihasilkan. Both produces hydrogen ion. Tapi this one, complete use of the hydrogen ion. There's no more hydrogen here. Tak ada lah. Okay, ada satu saja atoms of hydrogen and all of them are used untuk menghasilkan H plus ion. Tapi for acetic acid, CH3COOH ni, you can see although this H plus is produced, there are still more hydrogen here yang tidak digunakan. So this is partial. Itu yang dimaksudkan dengan partial production of H plus ion. So dalam that statement tadi tu, this one break apart. Untuk HCl, a strong acid, it breaks apart. Tapi untuk a weak acid, they stay intact, meaning the hydrogens here are still bonded to this molecule, this acetic acid molecule. So itu yang dimaksudkan dengan partially. Indigestion and heartburn is caused by an overproduction of stomach acid. So if you're suffering from this, what type of food should you avoid? Ini dah masuk dalam buffer. So we're talking about pH right now. So kamu kena ingat, our gastric juice tu, dia ada pH. So most of the time, it tends to gravitate towards neutrality. Tapi bila kita makan benda, dia boleh change dia punya pH. So that's why sometimes kamu dapat pedih perut, sakit perut. Because the pH dah sangat tinggi ataupun sangat rendah kalau dia acidic. So dia tanya kat sini, kalau kamu macam suffering for indigestion ataupun heartburn, jenis makanan apa yang kamu patut makan? So the answer adalah kita patut makan makanan yang tak boleh ubah pH yang pH dalam perut kita tu. So most of the the pH will most likely to stick to neutral. So the answer adalah foods that have a pH below 7. Maksudnya around neutral lah. A strong base in a water solution. Kamu kena lengkapkan statement. Which one of this is the most true, the most accurate? Okay, jawapannya adalah it dissociates completely in water, producing ion. Okay, completely dissociates into ion. That is a strong base. Okay, so kenapa? This is a critical thinking question. Soalan kibat. So why would a potato have a buffering system to survive its environment changes, to vary the pH according to the environment, to keep the pH of the potato low, to keep the pH very acidic? Why is that? Why would you think? Kalau kamu tak tahu, try to answer dengan with what you know. If that makes you have to hentam, try lah hentam. Kita akan discuss later. Apakah pentingnya kebolehan sesuatu bahan untuk mengawal pH? Why do you think manusia, kita punya perut, perlu kawal pH dalam gastric juice kita? Because kalau terlalu tinggi, kita akan dapat sakit macam tadi lah, heartburn, indigestion, sakit perut. So the same goes for every living thing, including a potato. So why would a potato need a buffer system? Okay, dekat 40 saya stop. 10 more seconds. The last 10 seconds. Kalau kamu nak hantam, it is right now. Okay, so the answer is the third one. Sorry, the first one. To survive if the environment changes. So kebolehan sama lah macam manusia tadi. Okay, kalau perut kita tu, our gastric juice is a buffer solution. So meaning dia ada kebolehan untuk mengawal dia punya pH, dia tak boleh mengubah dengan banyak. Tapi if we eat like a lot of food with a very high pH, dia boleh change dengan drastic. So tapi kita still tak mati because even if the pH is very strong, katakanlah dah macam 10, 12 sakit perut, but dia still tak menghakis dinding perut kita because our gastric juice is still a buffer solution. Dia boleh cepat-cepat reduce balik, tapi dia akan cepat-cepat naik balik. So that's the problem bila kita makan makanan yang problematic lah. If we have a disease or something, the pH will increase or go down, tapi dengan cepat. So that's why kita sakit perut. So the same thing apply untuk a potato. Dia ada kebolehan untuk mengawal pH to survive the changes in its environment. We also need to survive. So that's why kita ada kebolehan a buffer solution. I basically dah bagi jawapan kat sini. What might happen if buffers did not exist within the human body? Our blood and other bodily fluids might become too acidic or basic. Our stomach acid would not be able to break down food. We would not be able to process glucose within our cells, ataupun we will not be able to inhale oxygen into our lungs. So which one do you think is the right answer? Ramai orang kata, oh ada dua kat sini. Blood and body fluids become too acidic or basic. Stomach acid would not be able to break down food. So let's see which one is the right answer. Jawapannya adalah, you might be surprised. Our blood and other bodily fluids might become too acidic or basic. But to be more technical and accurate, all of these are correct. Okay, but the most accurate that might actually happen adalah blood and bodily fluids might become too acidic or basic. Yang ini salah sebab dia tak accurate. Okay, because our stomach acid is not the only buffer solution. Other bodily fluids also dalam badan kita adalah a buffer solution. Our organs, our limpa lah bahasa Melayunya. Spleen and liver also regulates pH. So that's where the blood, the oxygen, all the other things that go through kat dalam tu, they regulate the pH. So this one is the most accurate. They cover all of the aspects. So blood and other bodily fluids, which includes our stomach acid, could become too acidic ataupun too basic. Tapi technically semua ni betul, tapi tak tepat sahaja. Ini jawapan yang paling tepat. Okay, next slide. Buffer, what is the definition of buffer? Ability to resist pH change, to prevent pH from decreasing, to resist a pH increase, ataupun ability to resist pH change when small amount of acid added. Interesting. Okay, so the answer is adalah the ability of a solution to resist pH change when a small amount of acid added. Okay, so dia ada keyword tambahan kat sini. Bila sesuatu bahan yang berasid ataupun basic ditambah, dia ada ability untuk resist the change. Ini tak tepat. So it's like a trick question lah. You have to choose jawapan yang paling tepat. Walaupun ini betul, that is the words that is written dalam slide tadi. Tapi yang ini lebih tepat because they describe the situation. Because the pH will change kalau kita tambah sesuatu pada dia. Kalau dia on its own, dia tak akan ubah. Okay, so remember bila jawab soalan test nanti, pilih jawapan yang paling tepat. So the more hydrogen ion, H plus ion, the what? The stronger, the weaker, it neutralizes. Okay, jawapannya adalah, mana dia? The stronger the acid. The more H plus ion, the stronger the acid. Okay, remember, that's why saya buka saya punya whiteboard tadi. The strength. Okay, the strength of acid and bases bergantung pada satu benda sahaja, iaitu kebolehan sesuatu bahan untuk menghasilkan H plus ataupun OH minus ion completely. So lebih banyak dia produce H plus dan OH minus ion, lagi strong lah dia. What type of ion does a basic solution have? So good question, good fundamental question here. You have to master your fundamentals. When we're talking about basic solution, what are we actually talking about? Ada pilihan kat sini, hydroxide, hydronium, hydrogen, hydraulic ion. So which one is the right and the most accurate answer? Jawapannya adalah hydroxide. So remember, OH minus ion tu, nama dia adalah hydroxide ion. So yang selebih ni, please don't get confused ha. Maybe kamu sebab baru belajar hari ni, so tak familiar lagi. So hydroxide is OH minus. So bila kita cakap tentang basic solution, when we're talking about a base, that means we are talking about dia punya hydroxide ion. By the definition of Arrhenius theory. Remember dalam when we're talking about the strength of acids and bases, kita cakap from the aspect of Arrhenius theory sahaja, iaitu the ability of substance to produce H plus and to produce OH minus ion dalam water, in water. How would you best describe your science class this year, since this is your last class? What would you grade? We had our like first 3 ke 4 class dalam physical kan, face to face, and then the rest kita buat online. Kalau kamu tanya saya, I prefer dalam kelas lah because I get engagement from you guys more. Tapi online pun okay juga. Kita still boleh buat quizzes. We do the same thing yang kita buat dalam kelas. Cuma dalam it's not traditional lah. Maybe saya terlalu traditional. Ada dua orang jawab tak. Okay, thank you for your honesty. Very strange. Okay, so either way, my goal is just nak kamu faham lah. Okay, the topics that we learned today. Okay, strongest base. 04 pH scale lah. When we're talking about pH, 04, 8 dan 14, which one is the strongest? Ooh. Ada 7 orang, 2 orang. It's too long. So the answer is 14. So remember, base, alkali, the farther from neutral, the stronger it is. Sama juga macam acid. The farther it is from neutral, which is 7, the stronger is the acid. So 14 is the answer. So this is the opposite of that soalan tadi. Basically saya dah bagi jawapan. So saya nak move to the next slide. Anything that moves farther from the neutral value, itu adalah a strong acid. Dah on lama sangat, laptop saya pun dah slow. Silap ni. Sorry ya, this is wrong. Sorry, kosong lah jawapan dia, my bad. So betul-betul. Saya tengok ke atas ni pula, saya ingatkan ini PH 6. So jawapannya yang betul adalah kosong. Okay, value kosong sesuatu acid tu dia paling kuat lah. Okay, closer to 7. Yeah.
Sir, ada pitch kosong kah, sir?
Ada. Kita boleh calculate kalau pH tu kosong point something. Okay, not necessarily kosong, but it's kosong point something. Okay, kalau ada another subtopic dalam this ni, kita boleh calculate, kita boleh ada mathematical formula how to calculate pH. So pH is basically ada dalam lecture note, tapi saya tak sempat nak venture into that. There's a formula untuk calculate pH. So pH, dia punya formula dalam this subtopic ada 3 basically. pH tambah POH equals to 40. This is the first formula. The second formula is pH equals to, oh my god, let me buka the PowerPoint now. pH. Acid and base indicator, titration. I forgot the formula. It's in the next slide. No, lecture. No, I can just Google. Yeah, I remember now. pH is negative log of the. Saya ingat dah, sorry. pH is the negative log of the concentration of H plus. And the third formula is POH equals to the negative log of OH minus. So this is the formula untuk kita calculate pH. So kalau kita calculate pH, katakanlah we have a hydrochloric acid. Let's say we have hydrochloric acid HCl, and then it produces H plus ion dan juga Cl minus. So katakanlah saya tahu the concentration of HCl ni adalah 0.15 molar. So that means this one also dia punya concentration adalah 0.15 molar. So saya boleh calculate the pH. So the pH equals to negative log the concentration of H plus. So I just key in here negative log the value of concentration of H plus adalah 0.1. So I key in this value dalam calculator. Tekan negative log 0.15. I get the value here lah. Maybe 0.2 something. So that's how we get pH kosong, technically. Okay, to answer your question tadi. Cuan lah, kamu yang tanya. So kita tak sempat nak venture into this subtopic. So pH, kita boleh calculate. These are the 3 formulas. This is how we get the pH scale. Okay, 1 sampai 14 tu. pH 1 sampai 6 acid, 7 is neutral, 8 sampai 14. This is the formula that we use to get this pH scale. Yeah, so which is a good question actually. Next slide. So that's why maybe ramai jawab salah tadi. Sebab kamu tak expect kosong is the pH. Lagi 5 more minutes kita akan end our class. Okay, please bear with me. Kita ada lagi 9 slide. Kita akan power through. If the pH of a solution is tested and is found to be basic of the following choices, what would the pH have been? So this is just based on the pH scale lah. Kalau basic maksudnya apa? You know this already before you attend today's class. Sesuatu bahan itu base. Sesuatu bahan itu ada alkali kalau pH-nya lebih daripada 7. So in this case jawapannya adalah 9. 3 is acidic, 7 is neutral, 5 is still acidic, 9 is basic. Pun ada salah lagi. How's that? What does the pH scale do? What does it do actually? It describes. What does it describe? Tells a substance if it's an acid or base, measures the strength of weakness of acids and bases. So remember, pilih jawapan, pilih statement yang paling tepat, the most accurate. Ten more seconds and then I'll stop. I'll end the bukan stop the class, stop the question. Okay. So jawapannya adalah, kalau jawapan yang paling tepat, it basically both statement are correct. Okay. pH scale tells a substance if it's an acid ataupun base, and also dia beritahu the strength of the acid and base. The pH scale measure what? Bagus, Chuan tanya saya tadi. So secara tak langsung saya dah bagi jawapan to this question. So the pH scale measure the strength of an acid, the strength of hydrogen ions, the concentration of hydrogen ions, the concentration of an acid. So which one is the most accurate, do you think? Okay, so let's end it. Jawapan yang betul adalah the pH scale measures the concentration of hydrogen ion. So, 3 orang jawab betul, the strength of an acid. So the strength of an acid is betul, correct. Tapi macam saya cakap tadi, pilih yang lebih accurate. And dalam saya punya explanation tadi, saya dah tunjuk dekat sini. pH is basically kita measure, kita calculate the concentration of hydrogen ion. So kita quantify that. So this is pH. pH is the negative log of the concentration of hydrogen ion. So kita boleh calculate kat sini. So kalau pH dia 0.2, so it's a strong acid. Okay, so the most accurate answer dalam statement tadi adalah kita calculate the concentration of hydrogen ion. Lagi 2 more questions lah, and then that's the class. On the pH scale, what numbers are bases? This is cheating. No, tak cheat. This is too easy. Okay, so number of bases adalah from 8 to 14. Laju semua orang jawab. Semua orang tahu kan? Okay, so 2 more questions after this. Baru betul. Okay. This is the second last, penultimate. Which of the following is true about acids and bases? Okay, this is interesting. Berfikir sikit. The lower the pH, the stronger the acid. The higher the pH, the stronger the acid. The lower the pH, the more neutral. The higher the pH, the weaker the base. So it is not that hard. Cuma ada banyak benda yang kamu kena baca. So choose the one yang paling tepat. Oh, 10 orang dah jawab. Wow. Okay, 10 more seconds and I'll stop. Alright. So jawapan yang paling tepat adalah acid and bases. Saya lupa lah, banyak sangat tadi options. The first one, the lower the pH, the stronger the acid. The higher the pH, stronger the acid is wrong. The lower the pH, the more neutral the acid, salah. Okay, because 7 saja dia neutral. Lebih daripada 7, dia dah jadi basic. It's not even acidic anymore. And lastly, the higher the pH, the weaker the base. That is wrong. Untuk base, the farther it is from 7 is strong. Okay, last one, last question of the class for the semester. The higher the concentration of an acid, the stronger the acid. Betul ataupun salah? So kat sini, it's a bit of a tricky question. So kalau kamu baca betul-betul, you'll get the right answer. Remember balik the definition of a strong acid tu apa? Here kita define a strong acid by its ability to produce H plus ion bila larut dalam air. So dia kata kat sini the higher concentration of an acid. So the answer is false. Okay, remember the keyword untuk define the strength of an acid adalah the ability of that substance to produce the H plus ion. Kalau dia tak mention langsung tentang H plus ion, macam contohnya soalan ni, dia cakap tentang the concentration of an acid. So the concentration, kalau saya cakap tentang concentration, maybe kamu confused kat sini. Okay, katakanlah saya ada satu acid. Let's say I have another acid, ada guna HCl saja. Let's say I have hydrogen fluoride, hydrofluoric acid, sorry. So HF is hydrofluoric acid, it is a strong acid. Bila dia larut dalam air, dia boleh hasilkan H plus ion. Tambah F minus. So kalau dia boleh hasilkan H plus ion completely, this is a strong acid. Tapi dia tak mention anything about the concentration because concentration just means how much of this is dissolved dalam water. So kalau saya timbang, saya kata I prepare a solution of hydrofluoric acid ini sebanyak 10 molar, which is a very high molarity, a very high concentration. So it just means there are 10 molar of hydrofluoric acid yang larut dalam air, a beaker of water. Itu maksud concentration. Dia tak cakap langsung tentang how many ions are inside this solution. Dia only cakap tentang this molecule as a whole. Okay, so that's why kita tak boleh guna definition tu. Kita tak boleh guna this definition, mana dia? Kita tak boleh guna this definition. The higher the concentration of an acid is the stronger is the acid. Sebab contohnya macam dalam that slide tadi, CH3COOH, vinegar, cuka, acetic acid. This is a weak acid. Weak acid because bila dia dissociate in water, dia produce partially saja. CH3COO minus tambah H plus. Selebih ada hydrogen kat sini, tak dissociate dengan sepenuhnya. There are still hydrogen here. Okay, ada 3 atom lagi kat sini. So partially dissociate. So this is a weak acid. Tapi kita boleh prepare the solution up until how many 10 molarity juga. Same concentration as that. Tapi dia masih lagi a weak acid. Cuma a weak acid in high concentration. So maybe because it is a high concentration, bila kita detect dia punya pH, because the pH is the negative log to dia punya concentration. H plus. So because of the concentration of ni banyak, sebab kita ada prepare banyak molar kat sini, so the pH might be high. Maybe dapat 1 point something. Let's say, example. So the punya pH might be tinggi. Tapi it is still a weak acid. Remember, a weak acid can still have high pH reading. Sama juga macam a strong acid could have a low PH reading. It depends. It's very technical. Kita kena tengok from many aspects. So that's why kita kena pilih jawapan yang paling tepat. So on that note, I think that's it lah for our class. Macam mana nak end? Cannot end. Never mind. Okay. So remember, considering this is our last class, kamu punya test nanti. You have one more final test, which is dalam lagi 2 minggu. Lagi 3 minggu lagi lah technically dalam exam week. Saya belum pilih date lagi because kamu ada other exams kan. So kamu nak buat, which one do you prefer? Kamu nak buat after all the other exam ke nak buat sebelum all the other exams? Because final test only 20 questions and MCQ kita buat dalam ITEL. Macam hari itulah. So nanti saya discuss dengan Chuan lah. Okay, which one kamu discuss sama kamu, and then kamu bagi tahu Chuan, and then Chuan bagi tahu saya, and then kita akan pilih date based on your discussion. Okay, so untuk final test you have one more 20 MCQ questions. Dia akan cover daripada chapter 1, 2, 3, 4, 5, 6 and 9. Okay, kita skip 2 chapter. I apologize for that. Okay. So saya akan share lah all other materials, all revisions yang kamu dah buat selama ni. Nanti saya akan upload dalam ITEL. All the kalau ada tutorial dalam ITEL, dalam quizzes, saya akan share dia punya skema. So kamu boleh study untuk prepare for 20 questions saja. Okay, dalam 20 questions tu MCQ. Tapi dia akan involve lah calculations, theory, short essay. Okay, semuanya. And reminder, kamu basically ada tiga assignment. Kamu ada infographic, kamu ada gas law, and you have essay. Okay, remember untuk infographic and gas law, you have until the end of this month. 1 Julai is the due date. Untuk essay, kamu ada sampai 10 Julai, which is the end of semester. Okay, so please jangan lebih daripada due date because saya kena tanda and submit markah kamu. So kalau kamu lebih daripada due date, saya kena submit without your submission, without your markah. So kamu akan rugi banyak lah. Alright. So by the end of revision week, saya akan share kamu punya apa nama? What's the word? Markah carry marks. Bukan carry mark lah because kita tak ada final exam. Tapi all the assignments yang kamu dah submit, kamu punya tutorials, kamu punya infographic poster, kamu punya essay, and kamu punya gas law problem tu. So all these 4 will amount to 80%. Sebab 20, 20, 20 and 20. So kalau kamu submit ke semuanya, kamu dapat markah penuh untuk all 4 of this assignment. Kamu akan dapat 80% lah, which is already an A. Okay, so remember by the end of the semester, which is 10 July, kamu dah submit. The tutorial kamu dah buat, so no problem. So ada lagi 3 assignment tu lah. Okay, remember, infographic, gas law problem dan juga your essay. So 3 ni adalah 60%. So kalau kamu tak submit, rugilah 60%. So which is a steal sebab kamu boleh discuss sesama kamu. So I encourage discussion. You get together, get in your group, discuss macam mana nak tulis essay, macam mana nak buat that poster, macam mana nak jawab that 5 gas law problems. Okay, that is 60%. Tutorial kamu dah buat dah ada dalam ITEL. So that is 20%. And your final test nanti another 20%. So kalau kamu score your 20% dalam final pun, you will only get 20% only. Kalau kamu tak submit the other assignment, rugi. Okay, so remember, reminder, don't forget to submit. It's an assignment, so you can discuss. Kamu boleh tanya kawan-kawan, kamu boleh tanya saya kalau tak tahu macam mana nak buat. Okay, all, ada any other questions before we end our final class? Tak ada, tak sabar nak
Tak ada soalan, sir.
Okay, so kalau tak ada soalan, thank you all. I apologize barang kekurangan. Kita jumpa lagi untuk our final test. Hopefully next semester, kalau saya ajar nanti lagi in your final year, saya ajar lagi one more module. So thank you all. See you again. Stay safe.
Thank you,
Bye-bye.
sir. Thank you, sir.
Thank you.
Thank you, sir.
Bye.
Take care.
Take care. You too.